Okay, so in this problem, you want to find what's the t-value that will yield a half-life. Okay, meaning that the amount of the original value will be exactly half that of, or the amount at time t will be exactly half that at the original. So what I need to do first is I need to find my k value. I need to know what my k value is. So what I can do is use this information here. Okay, it says in 540 days, the radioactivity of the sample decreases by 31%. Okay, so even though I don't know what my original value and my current value are, I do know what the change is. So if I leave my original value some unknown quantity, e to the power of k times t, my t value is 540 days in this example, and it results in a decrease by 31%. So what does that mean is going to be left in my a value? It's not the original amount, not the full original amount, it's 31% less. If I remove 31%, what percent of this original value here am I dealing with? And this one, 1 minus 31 gives you 0.69. Okay, and so now when you divide by whatever your original initial amount was, those cancel. And then you set up the same way that we did the last problem. We have our e, the variables embedded in the power of e, so we're going to take the ln, or common log of both sides. I'm going to choose the natural log, once again, because I have a base e. So I get ln of 0.69 is equal to ln of e to the 540k. I'll move my power out front using the property, the power property. And then ln of e has a value of 1. And I can isolate and solve for k here by dividing by 540. And so this allows me to find my k value. Now, the problem doesn't ask me for my k value. Are you looking for your papers?
Yeah.
It doesn't ask me to find the k value, but I do need to know the k value in order to do my calculation. And so here, when I set this up, I'll take the natural log of 0.69 divide by 540. Bless you. And that is my k value. So if I move my decimal 4 places to the right, I have -6, 872 approximately. And here, if I move this 1, 2, 3, 4 places, so I have -0.000682. Again, it doesn't say what I need to round it to. I'm just going to leave it as this for right now. Okay, so this is my k value. It's negative. I expected that since it's decaying. And so I can go in and calculate my half-life because I want my original, or my amount at time t. So now I'm going to go back in to use this equation here, and I'm going to solve. I don't know what my original amount is still. I do know my k value is this number right here. I'm going to go ahead and just leave it ln of 0.69 over 540 times t. Okay, but I do know my half-life means that I'm going to have 1/2, exactly 1/2 of the original amount. So 1/2 of the amount at time 0. So if I divide both sides by a sub 0, those cancel. And then, again, it's a matter of calculating here. I want to find my t value, take the ln of both sides. I get ln of 1/2 is equal to the ln of e to the whole power, ln 0.69 over 540 times t. Move that out front. Ln of e becomes a 1. And so when I set this up, I'm going to divide or multiply both sides by the reciprocal here, 540 over ln of 0.69. 540 over ln 0.69, so those cancel, and I get my half-life, my t value. And when I do the calculation for this, 540 divided by the natural log of 0.69, And I'm going to multiply that whole thing by the natural log of 1/2. And when I do, I get my answer 1008.72. And that would be my half-life. Okay, the second part to this question then is to find how long will it take for a sample of 100 milligrams to decay to 52. And so here I would have to go back to my equation again right here. But I know my original amount. So here's my A sub 0. So I'll start with that. E to the power of my K value, I'm still going to just leave it as that ln 0.69 over 540 times T. The T is what I'm looking to solve for, and it's decaying to 52. And so that would be my amount A at time T. And this time I'm going to use the solve feature to do this, just to show the alternate way that this can be done. And so to solve this example, I'm going to use the solve feature, type in the equation. 52 is equal to 100 times e to the power of this whole quantity, ln 0.69 divided by 540 times t. So that's all in the power, and then I want to solve for t, and when I close this off, I get my solution 951.64.